Okay, so in this problem, we have a simple system consisting of mass of 7 kilogram controlled by a spring of stiffness 1.2 kilonewton m and experiencing Coulomb friction of constant magnitude equals 1 newton, which is given an initial displacement of 80 mm from the mid position. So the position for which the spring exerts no force, and look to determine the time which allows for motion to cease and the displacement from the mid position at that time. So from first principle, so we draw the body has so the body is connected to some spring and then has some friction on the floor. So the first at first we would excite the body by pushing it to the right and releasing. So it's we displace by initial displacement x naught, which is equal to this. Now when we release it, the body will move from right to left, right to left. So for right, no, before right to left. So when the body is moving from left to right, so left to right, we have the spring acting in this direction, friction acting in this direction. From Newton's law, we say sum of forces, so this is kx, this is F. Sum of forces is equal to mass times acceleration. So we have minus kx minus F equals mx dot dot, which implies mx dot dot plus kx equals minus F. And the equation of motion x at any time t will be equal to some constant a sine omega nt plus b cos omega nt minus f. When the body is moving from right to left, R to L, we have the spring constant, spring force, and then friction acting in the opposite direction. So once again, sum of forces equals mx dot dot. We have minus kx plus f equals mx dot dot. So mx dot dot plus kx equals f. The equation of motion x at any time t will be equal to some constant, let's say c sine omega nt plus d cos omega nt plus f on k. Sorry. Now, when the body is at the far right after the initial displacement, it has to move to the left. So we use right to left. Initial condition, displacement is 0, velocity is 0. So x at time 0 will be equal to c times 0. Sine 0 is 0 plus d, cos 0 is 1 plus f on k. So here the initial x at time 0 is x naught, so not x0, x naught. So we have x naught minus f on k to be equal to what? D. So we say x at any time t is equal to, so to find the c, before we make the substitution, let's find the c. So to find the c, we have to differentiate the function, right? And then substitute the d and find c. So x dot will be equal to c omega n cos omega n t minus d omega n sine omega n t, and this is constant, goes to 0. And the velocity is 0, c omega n is what will be remain. This will be 1, this will be 0. So from here, c is equal to 0. So you can say x at any time t when the body is moving from right to left is equal to what? X naught minus f on k multiplying cos omega nt plus f on k. Now, this is the equation of motion of the body when it's moving from what? Right to left. Now, let me make this clear. So when the block is excited, it's moved from right to left 1, then left to right 2. So this to and fro gives us 1 cycle, right? So if you move from here to here, to move from 0 to what, t on 2 pi on omega n, right? Then it will move from here to here again by another what, pi over omega n. So the 2 will give us 2 pi over omega n, which is the period. So at the instance where the body moves from the 0 to pi over omega n, crossing the 0 line, we have, let's say the displacement is x1. So x1 will be equal to x naught minus f1k cos omega n multiplying pi over omega n plus f1k. So x1 will be equal to minus x naught minus plus f1k plus f1k. So x1 will be equal to minus into bracket x naught minus 2f1k. So this is the displacement as the body reaches or complete the first half cycle. So to begin the next half cycle, that will be moving from left to right. So we use this equation. Now to use this equation, the initial condition x at time 0 for this equation will be the x1 in that the from right to left equation, which is equal to negative into bracket x naught minus what, 2f on k. So from here, x at time 0 will be equal to a sine 0 plus b cos 0 minus f on k, which is say x naught minus 2f on k is equal to b minus f on k. So this will be minus x naught plus 2f1k plus f1k equals b. And that means b is equal to x naught minus into bracket x naught minus 3f on k. So if you find the velocity and find the constant t, that will also be 0. So we can say x at any time t for the second half cycle, which is from left to right, will also be equal to minus into bracket x naught minus 3f on k cos omega n t minus f on k. Now, when the body has moved at say t equals pi over omega n to complete the other half cycle to give us a full cycle, the displacement, let's label it x2, will be equal to minus into bracket x naught minus 3f on k cos omega n times pi on omega n minus f on k. So x2 will be minus x naught minus, so before we do that, this one will give us minus 1. So we have x naught minus 3f on k minus f on k. So x2 will be equal to x naught minus 4f on k. So what we observe is that when the body moved from left to right, we subtracted 2 times f on k from the initial position. When it's moved from right to left, we subtracted another 2, giving us 4. So when we move 1, we subtract 2. When we move 2, subtract 2. So the displacement at any end will be equal to x naught minus r times 2f on k, where the r represents number of what, half cycles. Now the system will stop at the instant where the spring force is less or equal to the frictional force. So we say x is less or equal to f1k. Now this x is any displacement after any half number of cycles. So xn, which is equal to x naught minus r times 2f on k, should be less or equal to f on k. So we can say that R is greater or equal to x naught minus f on k all on 2f on k. In our problem, we were given the mass to be 7, k to be equal to 1.2 times 10 power 3. The initial displacement to be 80 mm, which is 0.08 m. And then we are given f to be equal to 1. So here r, you can say r is greater than or equal to 0.8 minus 1 on 1.2 times 10 power 3 all on 2 times 1 all of 1.2 times 10 power 3. So from here we can see r is greater or equal to 46.5, approximately 47. So from here we know that for 47 half cycles the system will stop. Now, knowing that for each half cycle the time is pi over omega n, the time taken to stop will be equal to 47 times pi over omega n. But omega n is equal to square root of k on m, which equals square root of 1.2 times 10 power 3 all on 7. And that gives us 13.093. So the time t will be equal to 47 times 13.093, which is equal to, sorry, so the time t will be equal to 47 times pi all over 13.093. So the time will be equal to 11.27 seconds. And the displacement from the equilibrium position, x n will be equal to x naught minus 47 times 2 f on k, which will be equal to 0.08 minus 47 times 2 times 1 all on 1.23 times 10 power 3. And that gives us 0.0016 m, which implies x to be equal to 1.6 mm from the equilibrium position. So I did all the above because it stated we should do it from the first principle. But I think you can also start from here. You can start from here. Right? So you make this assumption, then you state this, you bring your value, then you continue from here. All right. All what we did earlier was to establish this condition. All right. Thank you. So yes, if you enjoyed this session, kindly subscribe to the channel. We are pushing the channel to 1,000 subscribers by end of next month. Your support is needed. We need your help. Thank you. Like, subscribe, and share. Bye bye.